Hello, welcome to FM Live. My name is Mike Usrey, and in today's video, we're going to be talking about boost controllers, why you might need one, what kinds there are, why you might want one versus the other, that kind of stuff. If you have questions about boost controllers or why you might use one versus the other, any of that kind of stuff that's related, put those in the comments down below because I do try to answer questions throughout the video as much as we can. Without further ado, let's go ahead and get right into it. So, why are we talking about boost controllers? Let's just start off. What the heck is a boost controller? So we're talking about boost controllers specifically because we like turbos. Turbos are good, boost is good. For those of you that are into superchargers, no hate, but this video is not for you because superchargers are driven off of engine RPM and a belt system. They produce boost based on that RPM and it's very mechanically driven. With a turbocharger, you have exhaust gas that comes in one side, spins a wheel, that wheel's connected to the other side, pulls air in through here, boost comes out here. So it's an exhaust-driven supercharger, and to be able to control this, there is a little flappy door here. This is called your wastegate door, and on top of this, there would normally be an actuator. This one's not mounted because I have to show it to you later, but basically, this is a little spring mechanism, and its job is to open this wastegate door when a certain boost pressure is reached, so that way you don't overshoot your boost level target. So, to do that, these little guys, they are basically springs. Inside here, this is just a canister, and it has a diaphragm roughly in the middle, and it has a spring, and that spring, basically, it allows this, it's on this side, it pushes against the diaphragm and it basically pulls this rod back in toward it. There's a few different styles and we're not going to get into all the different kinds of wastegate actuators that there are out there, but for a very basic actuator, this is what it is. So spring pushes against the diaphragm and it pulls this, which would go onto here, it pulls it shut to keep that door closed. So as you add boost pressure, you're going to be putting that boost pressure through this little reference nipple. There's just one on this guy. And that boost pressure pushes against the spring and it causes this rod to extend. And as that happens, that rod extending pushes the door open and that releases gas, exhaust, that would otherwise go through your turbine housing and spin the wheel. It allows it to bypass that. It vents it off. And that keeps the turbine housing from spinning as quickly, which means that you get reduced boost or basically controlled boost from your compressor side. So instead of being reliant on belts and engine RPM and that kind of thing for boost like superchargers, a turbocharger uses basically a few moving parts, swinging gate, a spring, and pressure to be able to regulate how much boost the turbo makes. Hopefully that is a simple enough explanation. I did try to make it pretty straightforward. If you guys think that this is something we should talk more about in depth, let us know. Put your comment down below. Maybe we'll do a video all about that. But today, we're not talking about that so much as we are about boost control using another methodology like a manual or electronic boost controller. So with these guys, these actuators, they are a set amount of boost pressure that they can regulate. The spring has a certain amount of pressure or tension that it wants to be able to push to try to keep the diaphragm away from this backside to be able to pull that wastegate shut. So like in the instance of this particular actuator, this is for 2560. It's about 7-8 pounds. So that is how much pressure the spring pushes against it. And that's called mechanical base boost. And with this setup and just having your reference hose and all of this hooked up, you would be able to run as much as that spring is able to press against or resist before the door opens to release that excess gas to prevent it from going beyond 8 psi. So if you want more than 8 psi, there are aftermarket actuators that have different springs, or you can pull them apart and put different spring pressures in them. But there's also a simpler method. And for most people, that method, without having to change these out, because they can get pretty expensive, is to use a boost controller. So today, boost controllers, these guys, these are just two simple examples of what we're going to be covering. Over here, I've got a Turbo Smart manual boost controller. You can see it's just got a little nice knob on top, an in and an out, and a little arrow to point which direction the pressure is supposed to be moving. And then this guy, an electronic boost controller, and this is it's a valve, an electronically controlled valve, and I'll talk more about that in a minute. But it is obviously got some wire, and it does kind of the same job, just with electricity involved. These two are very simple and inexpensive options. Both of these are well under $100 for most of the simple options. There are other kinds of boost controllers out there that get pretty fancy. There are, I've even seen some that are like a dual reference gate. Basically, they have like multiple ports, and you can have a high and a low boost setup. That's cool. We're not talking about that today. Let us know if you want to talk more about that in a future video. There's also versions of this that are even smarter, that are basically connected to an internal map sensor that reads how much pressure, and it will adjust your boost on the fly. And some of them have like these displays with buttons, and you can configure it, and that's all really cool. But again, we're going to stick to the basic stuff for right now. But either one of these will allow you to plumb it up along with your stock actuator and basically turn the boost up. So if your base boost is 8 psi, you can use either of these solutions to be able to raise your boost beyond that base mechanical base boost limit. So roughly speaking, with these kind of simple contraptions, you can go to upwards of about double. So, you know, with this actuator, you could go to maybe as high as about 16 psi. That's about the limit, and again, I'm going to stay pretty simple here, but if you want to raise your boost level because maybe you are trying to aim for 10 psi, 12 psi, all you need is a boost controller. You don't need to swap a bunch of other components. This is the easy button for most people. Let's stop for a brief second and look at this on the car, because I've talked about bits and pieces, but let's show you what it looks like in the vehicle. Hopefully that'll kind of glue the whole understanding together. So here, I've got, let me get to here. I've got the turbocharger. This is on our NANB Stage 1 Turbo Kit. And you can see right here on top, we've got that big canister. That's our wastegate actuator. And then this hose is coming down, and it leads to a manual boost controller. This is actually an older version of the same Turbo Smart unit I was just showing you. But it comes in, out, well, I guess other way around, but this is the inside. And this other hose comes down here, and well, here, you can kind of see it just barely. It comes right off the compressor housing. So obviously, this side of the turbo should be making boost pressure whenever you are romping on it, hopefully. And that boost pressure sends some pressure, a little bit, down the hose through your boost controller to the actuator. So in a very classic routing, this is the simplest form of using a manual boost controller. Your electronic boost controller can be routed in much the same fashion, but in essence, without this boost controller, you'd have your hose from your compressor housing going directly to the actuator directly for mechanical base boost. But when you have a boost controller in the circuit, this is how you would route it up for a simple internal wastegate setup like this turbo, where it's basically just in line, and it's going to be modifying that signal. So, speaking of modifying the signal, what does it do? Now we know that it's installed in this manner. We know that it can raise the boost. What is it actually doing? Both of these, and pretty much any boost controller, they are more or less just measured boost leaks. They are venting off a little bit of that boost pressure, depending on where you have the knob set or how you have this configured, and venting off a little bit of that pressure. So that way, as you have the pressure fed to your actuator, even if your turbo's making 8 psi, if you say, no, I want to turn this up a little bit, it's going to vent some of that pressure, so that way the boost that's getting to here is actually lower than what the compressor housing is making. It does that via little holes in the boost controller. It's kind of hard to see on this one. This is the older style one, where basically if you've ever wondered what these holes in the side of the bodies are, that's exactly what that is. That's basically where that excess boost pressure is getting vented to. So these are restriction points, and it's either allowing some more or none of that boost pressure through to some point or extent. These guys, I'll take this one apart so you can see a little bit of what the insides look like. If you've ever worked on carburetors with needle valves, it's kind of like that, not quite. There we go. So let me hold this up in front, maybe that'll help you see. But see how there's this kind of needle point down here. It's not actually sharp or anything, but that point sits down into a little socket, and it restricts that boost airflow, essentially, to the actuator, and either diverts it or lets it through, depending on how far down into the cavity it is being manipulated. So to show you maybe a little bit better, I've hired an expert, absolutely phenomenal artist to come in and do some displays. That way we can see a little bit better what's going on, because showing you the little bitty parts is cool, but it's hard to see, especially on camera. We have our fun maker here, making that boost pressure. And just like I pointed out on the car, we have that little reference point where most people are going to be sourcing their boost pressure. Following that here, I've got our electronic actuated boost controller here and our manual version up top. You wouldn't normally run them together, but for the sake of this drawing, having them both on here was easy. So let's talk about the manual one first. Here is that same piece where you have boost pressure coming in. It goes through a little passage, and then it's restricted how much flow, depending on where this is threaded into the body. And then these are the vent passages that are just above it. Different boost controllers, you know, brands, that kind of stuff, will look a little bit different, but they all function about this way. And then whatever pressure isn't vented off, depending on where the position of this needle is allowed to pass through and then over to your wastegate actuator. So that is a very simple tool. It's basically a piece of plumbing hardware, essentially. That's all it's doing, is restricting flow and either allowing it to go to the actuator or venting some of it off. The electronic version is kind of the same, but it has a little bit of a different trick up its sleeve because it does have electronic control. So it has two wires, and it's got this black cap, and it's just a electronic solenoid. It's moving a little bitty piston inside this unit, and it's diverting air from one of the little valves to the other. I'll kind of show you this one, where it has a port in the front, and then on the sides, they're labeled 1, 2, 3. And basically this guy, it's going to be swapping what airflow or what channels the airflow can go to depending on where the position of the plunger or piston is. So same thing coming out of the turbo, got that positive pressure coming into, usually this is going to be port 3 on your actuator. I'm sorry, on your boost controller. Keep using the wrong term, my apologies. Port 3, and then it comes in, and then either this piston, it's not drawn to scale, but you get the idea, can move up or down depending on if this is powered or not. So it can move up, down, and either allow passage out the 1 or the 2 ports on this controller. So depending on where it's moved, if you have power applied to it or not, it'll either let that pressure go through to the actuator, or one of the ports is generally left open. So just like it has venting ports on that manual version, so does the electronic version. Same kind of function, but you can control when that piston moves, so that way the boost can be a little bit more finely tuned. And we'll talk more about why that might be an advantage for some people in a little bit. But essentially, that's how these guys move, or allow air to move. They still function more or less the same way, letting some or less of the air pressure get to the actuator to do its job. This one, you know, it's pretty straightforward. The manual boost controller, you just turn the knob, very straightforward. That's really the beauty of the manual boost controller, is that you don't need anything special other than your fingies to be able to turn the knob and make it do the thing. The electronic boost controller, as I mentioned, it's got two wires. These wires have to be hooked up and controlled by something. basically they want 12 volts to be able to actuate that piston inside there. And one of these is power, one of these is ground, doesn't matter. Solenoids don't care, they're non-polar. But you have to have something to control it. Now, I suppose you could hook this up to a switch and just flip it on the dash. That's a terrible plan. I definitely don't recommend you do that, because then you'll get all the boost pressure and probably pop your engine. Most of the time, you're going to be using an aftermarket ECU or some kind of a smart controller, so that way this is basically moving that piston up and down at a certain frequency and giving you a overall amount of, it's been open this long and it's been closed this long, and that's how it basically makes the restriction in airflow. So instead of having a needle valve that is pushing down to restrict that airflow or divert that airflow, this has a pulse width modulation. There we go, that's the word. So that way that duty cycle for how often the piston is up or down, that determines how much airflow or how much boost pressure is allowed to go through which passageway. And so that's how you can restrict how much boost pressure goes to your actuator, so that way it can delay when it is opened. So if you have, say if it's an NA or NB, you're running an aftermarket ECU, usually they'll have some kind of a control built into the programming, the software, that you can set up that control for this little guy to make it run X amount of boost. You do have to configure it just like this, you know, turning the dial doesn't equal 3 pounds or 6 pounds per click or anything like that. Same thing with this guy. The duty cycle is a percentage, but you still have to figure out on your car, your turbo, your setup, how much a little bit extra percentage is in PSI or KPA, whatever you want. Basically, it has to be configured. But you can't do that without some kind of a controller, an aftermarket ECU, or if you have one of those smart gauge modules, that they can be pretty handy. We're not going to cover those in this, but essentially this is mostly for the people that do have aftermarket ECUs in the NAs and NBs. NCs, NDs, the factory computers don't really have outputs that you can take advantage of the same way without taking away some of their other functionality. So, sorry, NC, ND people, this is not going to work out of the box for you either. Generally speaking, at least with our Stage 1 turbo kits, this is not really a concern for most people. This is usually something that people that are going above and beyond, especially race car purposes, that kind of stuff, might want for more boost. Usually built engines, or even just, of course, aftermarket ECUs with more flexibility for fueling, ignition, yada yada. So, if you don't have a laptop and you don't have an aftermarket ECU, this one is probably off your list. That's a lot of talking about boost controllers. Are there alternatives to boost controllers, or what other options do you have? Because there's a lot of finesse to setting your boost and getting it right, because obviously you don't want to blow your engine, of course. So what options do you have besides that? So with some of the turbos out there, you have a actuator that this rod is fixed. It doesn't have any adjustment to it. But there are some versions out there that have adjustable ends. So like this one, you can see this end actually can thread in or out, and that reduces the length or lengthens the rod as a whole. Why does that matter? When this is on your turbocharger, and you have it set, I don't have a bracket here, I apologize, but you have it mounted usually to the compressor housing, that needs to have a certain amount of preload when it's basically not having any boost run to it, and that holds the wastegate door in place. If you have less preload, that wastegate door is ready to open a little bit sooner and takes a little bit less pressure to start opening. So by reducing the length of this actuator rod, you can add more preload, and that holds, sorry Travis, that holds the wastegate door tight against the inside of that turbine housing. That means that it takes usually another couple, 2-3 psi worth of effort being fed through that actuator before the door starts to open, because it has to overcome that preload before it can actually also do the same effort as the pressure of the spring that's inside the actuator. So that is an option. Not every turbo has one of these. Not every turbo has the provision to mount one of these. So unless you have either a custom-made actuator, one that comes from the factory with it, or if you're just handy with making your own brackets, this may or may not be an option for everybody. This is a handy method. Generally, adding preload usually is something that can get you a few PSI more. It's not something that you can double the pressure. Like if this is 8 PSI actuator, you can't necessarily get 16 PSI out of it. It's something that you can usually get a couple, maybe 3, 4 PSI if you're lucky, that you can give it more preload to get that. So it's really a limited option for how much boost pressure you can get from just adding preload. I think let's stop for some questions here. We got some in advance. I'll take some of those first, and then we'll see if we have any live questions. So again, if you have questions about any of this that I haven't covered, drop your comments down below, and I'll get to them after these. The first question, which is probably the most common question that we had about this, is which one is better? It depends on your circumstance. Do you have aftermarket ECU? Do you have any kind of means to be able to use an electronic version? If the answer is no, then manual is probably just the easy option because that's what you have access to. It also means that you don't have to whip out your laptop or your tablet to be able to do any tuning if you need to on the side of the road. This, you just get out, twist the knob, get back on your merry way. Now this guy, the electronic one thing I didn't talk about earlier is that because it is something that has to be adjusted with a laptop or tablet, you have to have some sort of control and software. One of the advantages to this is that you can set it up to run lower or higher boost based on what gear you're in, based on what speed you're going, based on if you have wheel spin or not. You can actually configure your ECU, depending on how smart it is, to do all kinds of clever things so that way this controller can run more boost if you have enough traction and power to do so, or less boost if you need to focus more on traction, or if you need to focus on, like say if you wanted to set up a valet mode for letting somebody else drive it that's not as familiar with that much power. So there's more flexibility in this one, but you also have to configure it. So which one is better? They both have advantages. It kind of depends on your situation. There isn't a clear-cut answer across the board. Do FM turbo kits include boost controllers? No. And the reason being is that most of our turbo kits are set up to run 8-ish PSI, or sometimes a little bit less depending on how much power it's actually making, what elevation you're at, that kind of thing. So with that method I was talking about earlier, where you either shorten this rod or you can also shim this actuator mounting bracket to add more preload. Usually, if you need a little bit more boost to achieve it with a low boost kit like our Stage 1 turbo kits, that's all you need for most people. Now, that being said, if you're at higher elevation, say above 5, 6, 7,000 feet in elevation, some of you that are in the Colorado Rockies may need a boost controller to be able to compensate even further because you have such a lack of barometric pressure. At sea level, barometric pressure is high, 100-ish kPa. Up here where we are at about 4,600 feet, it's usually about 83, 84 kPa. And all of this to mean that basically there's less atmospheric pressure and barometric pressure, and barometric pressure plus boost pressure equals the kind of horsepower that your engine is actually putting out, or what your turbocharger is able to add to it as a total. So to be able to compensate for that lack of barometric pressure, you can actually turn your boost up a little bit more than you would if you were at sea level. So if you wanted to reach the 165 wheel horsepower of our NA6 turbo kits, that kind of thing, you might need a boost controller to compensate for your lack of barometric pressure because you can turn the boost up a little bit more. The engines don't really know. Like they don't care if it's barometric pressure or boost pressure, they just know pressure. So the combination of the two, that's what we aim for when we're setting up tuning for our turbo kits. So you can compensate for that lack of barometric pressure by adding a boost controller. It's not always necessary. It's usually for higher elevation setups, at least with our turbo kits. But standard, they are not included. We do have them available if you want them. We got a question about our upcoming NC turbo kit, if that is going to be enough for high elevation driving to be able to set this adjustment and add preload. Probably. At least where we are, and we've driven ours up to about 10,500 feet, I believe, with our NC turbo kit. And you do have just enough adjustment for that to be able to add the preload onto, this is actually the 2860 actuator that we use on those turbo kits to be able to get to the kind of power levels that we are expecting at sea level, even with the lack of atmospheric pressure at those higher elevations. So this is not necessarily going to be the gospel truth. Every car is a little bit different, but, and everybody, of course, if you drive higher, maybe you're in Leadville. We haven't tested in Leadville. That's like over 12,000 feet. Don't know. If you have questions about it, give us a call and we can talk about it a little bit further. But at least with the NC Turbo Kit, with our driving, the amount of adjustment that you have there should be fine. Here's another question we got. And basically, when we're talking about the routing for the hose to be able to get your boost source from the compressor housing to your actuator, usually it's a short little length, a couple of feet maybe. But let's say that you had a really long length of hose. Would there be a point where that hose is too long that it would actually cause an issue with the kind of boost adjustment, or how much you would need to do tuning-wise for preload or whatever? Would it cause a problem, basically? Yes, to an extent. You'd have to have a pretty long hose for that to be a problem. The amount of air that is moving through one of these hoses, there we go, I'll just pop off this little guy. This is a pretty standard silicone, like 4mm silicone reference hose that we use a lot of times for the boost reference to the actuators. There's not a lot of volume, so that pressure is able to move through here because it doesn't require a ton of air physically moving. If it were a much larger hose, that might be a problem, but a smaller, like 4mm diameter or thereabouts, you'd have to have a really long length of hose before that became a problem. We're talking, probably 8, 9, 10 feet plus, but we're talking about a Miata. Your boost controller is probably going to be in the engine bay, relatively close to your turbo. So unless you're running your boost controller in the trunk, it's probably not going to be a problem for you. So, good question though. That's one that we don't often get. There's a lot of info in here. Hopefully this helped. If you need clarification because I was not as clear as I could have been on any of this, feel free to ring us, send us an email, shoot us a message, whatever. We'd be happy to talk to you more about this in your specific questions to cover your application. This is something that I tried to keep it on a pretty high level, but it's easy to get off into the weeds, as you could probably tell. I tend to go on and on. My apologies. Thank you so much for listening. But I will leave it there for now because I think that that's shy of beating a dead horse as close as I'm going to get. So, thank you very much for watching. We really appreciate your time. If you like this kind of content or these kinds of technical talks, please let us know in the comments down below. If you have suggestions on what other things you'd like us to talk about, of course, leave us comments about that too. As always, we really appreciate you. This kind of stuff is fun for us, but it does help us out a little bit. So if you can, subscribe. That way we can continue doing these kinds of videos for you. And hopefully this is something that can live on and be a good, useful reference for lots of people in the future. But until next time, thank you so much. We will see you next Thursday about another fun and interesting topic here at FM. Have a good one.